Good morning, everyone. I'm Priyadarshini Balakrishnan from Kumaraguru College of Technology. As a part of KSI Social Internship, our team worked under the domain Autonomous Mobility. While autonomous mobility is often linked with vehicles, it also extends to smart automation in agriculture and rural development. In our project, we applied this concept to waste management, focusing on delays and cost caused by the manual manure testing in rural composting centers. We propose an AI-powered IoT device that can analyze the nutritional composition of manure on site and real time using sensors and AI models. This minimizes the manual effort and reduces the dependency on labs and support farmers with faster and reliable decision
To
making.
wrap up, our project introduces an AI powered IoT device that makes compost testing autonomous, affordable, and almost instant. The device combines multiple sensors with AI to deliver results in less than 2 minutes. By doing so, it reduces costs, removes the need for distant lab testing, and supports farmers with quick, trustworthy insights. Here are the key takeaways: real time testing directly on site, cutting out long waits and uncertainties. Consistent manure quality, which gives farmers the confidence to adopt organic methods. And affordable and scalable design, which means the same concept then later be applied to soil or water testing in rural communities. In short, this project isn't just about technology, it's about empowering farmers, supporting sustainable agriculture, and bridging the gap between innovation and rural development.
Hi, hello. I am Saravanan from ADS department. Here I am going to discuss the problem statement which has been chosen from our social internship. We have visited a smart city plant. In the smart city plant, they convert the biodegradable waste into a natural fertilizer. For the conversion, they need to secrete the biodegradable waste and they need to process the biodegradable waste. In order to check the each day of the biodegradable waste, they need to test the nutrition level. So they need to give a sample test to the outside of the lab in order to check the nutrition level. So it takes a few weeks of times and it is not cost efficiency. So in order to avoid this issue, we have tried to design an IoT device in order to fix this issue. This IoT device will be most cost efficiency and it will reduce the time to give the proper result.
Good morning, everyone. I'm R. Mukesh from AIDS department. Today, I'm going to explain project, my team project in social internship. Actually, our team project is about some soil moisture sensor using AI technologies. So my part is what are the technologies I use to map to this challenge. My point of view, the sensor I used here used in this project are NPK sensor. It is an ion selective sensor with electrodes and also a moisture capacitive sensor and pH sensor and temperature DS18B220 sensor and also NA sensor for organic matter. And also what hardware we use in this system to develop this project is we use ESP32 hardware with Raspberry Pi Pico on solar and battery power LCD display. And to operate and implement software-based codings, we use AI/ML model like artificial intelligence and machine language model like regression to interpret sensor data, edge computing for fast results, cloud dashboard plus mobile app for records. Actually, we develop a mobile app by using this front-end back-end AI/ML algorithms, and also we combine it with the soil sensor. And to combine this sensor, there's not much new technologies used. The technology used here is Wi-Fi and Bluetooth for real-time syncing. So by using all these sensors, hardware, software connectivities, we develop a AI-based soil moisture data sensor, which is helpful for further gardening purpose. Thank you.
Now, I will be explaining about the societal and technical impact of our solution. So, the first is the societal impact, and first point is it reduces cost and waiting time for rural waste centers. So, the one of the pain points we saw in our field visit is the centers has to manually collect the manure and has to pack it and send to a distant lab to check on the nutrient content on the manure. So this itself consumes a lot of time, and also it is costly as the transportation and lab cost are high. So our solution helps in reducing it by bringing a portable device that can check on the nutrient content. So second is it empowers farmers to trust and use organic manure more confidently. Since our solution helps in detecting the nutrient content in the manure and also in the compost, the farmers can check the nutrient content of the manure in real time before buying it. So it can also help in not just checking the nutrient content in the compost level, but also in the manure level. So the farmers can confidently buy the manure. The third is that it promotes sustainability by reducing chemical fertilizer dependency. This is also similar to the second point. It promotes the farmers in buying the natural manure over the chemical fertilizers. So it also promotes the sustainability. The fourth is bridges the technology gap in rural areas. Since the rural areas cannot afford for high-tech technologies, such as these research labs where the manure and the compost are sent just to check on their nutrient level, our solution also helps in bridging this technology gap in rural areas. The fifth is it supports government and NGO goals for sustainable rural development. Uh, Government and NGOs has set some goals for sustainable development in rural areas. One such is maintaining sustainability. So what it says is farmer can depend on the organic manure and not on chemical fertilizers for his crops. That is, the organic manure is gotten from is get from just the organic waste such as vegetables, fruits, other such things that is get got from households, and also the crop waste which can also be get from the farmlands. So, in turn, these wastages are converted into manure and is supported for the crop development. So, sustainability is also achieved. The last point is it reduces manual workload for workers in compost monitoring. So, last is we also saw this pain point, that is when once the manure or compost is packed and sent to the research lab, the all the work in the batches of the compost are halted, and only when the result of the compost in nutrient level is received, it can be moved to the next batch or stay there. So it also reduces the manual workload in monitoring the compost.